Some warplanes were so advanced, so ambitious, and so packed with technology that they became more of a burden than a blessing. Throughout history, militaries have dreamed of creating the ultimate aircraft, planes that could outrun missiles, dominate the skies, or terrify enemies just by taking off. Engineers poured their brilliance into radical designs, stuffing them with cutting-edge engines, electronics, and features that looked decades ahead of their time. But there was a catch. The more complicated these planes became, the harder they were to build, maintain, and actually use in war. Some were breathtaking to look at, yet dangerously unreliable. Others flew faster and higher than anything else in the sky, but burned through budgets so quickly they were scrapped after only a few years. In this video, we'll uncover the most over-engineered warplanes ever built, from German jets that arrived too late, to Cold War bombers that cost more than they delivered, to modern fighters still struggling with their own complexity. These aircraft were marvels of design, but sometimes brilliance became a burden. Before we dive into specific aircraft, it's important to ask, what do we actually mean when we call a warplane over-engineered? In military aviation, the term usually describes an aircraft designed with technology that looks brilliant on paper but turns out to be impractical in real combat. Over-engineering often happens when designers chase innovation without considering the harsh realities of war, logistics, maintenance, and cost. The result is a plane that dazzles with complexity but struggles to deliver consistent performance on the battlefield. A perfect way to understand this is by comparing two very different approaches. On one side, you have the P-51 Mustang of World War II. It wasn't the most exotic design, but it was simple, reliable, easy to produce, and devastatingly effective in combat. On the other side, you had experimental aircraft packed with advanced engines, exotic materials, or radical designs. Many of those prototypes looked decades ahead of their time, but were so fragile, expensive, or difficult to operate that they were more of a liability than an asset. This is the core issue with over-engineering. A weapon's value isn't measured by how advanced it looks, but by how well it performs under pressure. A plane that can be produced in the thousands, repaired in the field, and flown by average pilots will almost always have more impact than a technological marvel that sits grounded in a hangar waiting for spare parts. History shows us that too much cleverness can be just as dangerous as not enough. When engineers and governments become obsessed with building the perfect aircraft, they often end up creating something too costly, too complex, or too unreliable to play a decisive role. These designs might impress in demonstrations, but they fail in the messy, unpredictable reality of war. So when we talk about over-engineered warplanes, we're really talking about that tension between brilliance and practicality. Machines that were ahead of their time in design, but behind when it came to real-world usefulness. And as we'll see, history is full of examples where too much engineering genius turned into a burden rather than a breakthrough. Our first example of over-engineering takes us back to World War II, to a plane that looked like it had come from the future, the Messerschmitt Me 262. This German jet fighter was the first of its kind to enter combat. Sleek, fast, and unlike anything the Allies had ever seen, the Me-262 could fly at speeds over 500 miles per hour, leaving propeller-driven fighters like the Spitfire and Mustang struggling to keep up. On paper, it was revolutionary, a weapon that might have changed the entire air war. But here's the problem: the Me-262 was also a victim of its own complexity. Its jet engines were far ahead of their time, but they were fragile, short-lived, and prone to failure. Some lasted only 25 hours before needing replacement. Keeping them running required constant maintenance, specialized parts, and mechanics with advanced training. In a war already straining Germany's resources, that kind of upkeep was nearly impossible. Production was another challenge. The Me-262 was expensive to build and difficult to mass produce. Germany managed to construct fewer than 1,500 units, and of those, far fewer ever saw real combat. Allied bombing raids targeted factories, spare parts were scarce, and even when aircraft rolled off the assembly line, they often sat grounded for lack of fuel or trained pilots. Then there was timing. Although the Me-262 first flew in 1942, political indecision and technical problems delayed its full deployment until 1944, far too late to turn the tide of the war. By then, Germany was already losing control of the skies, and even the world's first operational jet fighter couldn't reverse that reality. In many ways, the Me-262 symbolized the danger of over-engineering. It was an extraordinary aircraft, decades ahead of its rivals, but it arrived too late, cost too much, and required too much care to make a real difference. Instead of saving Germany's war effort, it became an expensive curiosity, proof that brilliant design doesn't always equal battlefield success. The Me 262 may have been revolutionary, but it was also impractical, a marvel of engineering that ended up being more of a burden than a breakthrough. The next example of over-engineering came during the Cold War, with an aircraft that looked like it belonged in a science fiction movie, the Convair B-58 Hustler. Sleek, delta-winged, and capable of flying at twice the speed of sound, the B-58 was the world's first supersonic bomber. When it debuted in the late 1950s, it was considered a technological masterpiece, a symbol of American air power at the height of the nuclear age. Its performance was dazzling. The Hustler could cruise at Mach 2, reach altitudes above 60,000 feet, and carried advanced avionics systems far ahead of their time. It set numerous speed records and looked every bit like the future of strategic bombing. But as impressive as it was, the B-58 quickly revealed the pitfalls of over-engineering. The aircraft was incredibly expensive to build and maintain. Each plane cost far more than earlier bombers, and its maintenance demands were staggering. It had a very limited range, requiring frequent refueling, which restricted its practical use in long-range nuclear missions. Even worse, the B-58 was notoriously difficult to fly. Pilots described it as unforgiving, with little margin for error. Accidents were common, and the aircraft earned a reputation as dangerous for its own crews. In the end, despite its brilliance, the Hustler lasted barely a decade in service. By the late 1960s, it was retired, replaced by more practical designs like the B-52 and eventually the B-1. The B-58 remains a striking example of a warplane that was too advanced, too costly, and too difficult to sustain, a marvel of engineering that proved more trouble than it was worth. Our next story takes us to Canada in the 1950s with an aircraft that has since become legendary, the Avro Arrow. Sleek, white, and futuristic, the Arrow was a cutting-edge interceptor designed to protect North America during the Cold War. On paper, it was decades ahead of its peers. The Arrow could reach speeds of Mach 2, fly at altitudes over 50,000 feet, and carry advanced radar and weapon systems. Pilots who tested it described it as smooth, powerful, and years ahead of anything else in the sky. For a nation with a relatively small defense industry, producing such an advanced aircraft was a staggering achievement, but brilliance came with a price. The Arrow was enormously expensive to develop, consuming a huge share of Canada's defense budget. At the same time, global strategy was shifting. The rise of long-range ballistic missiles made high-speed interceptors seem less critical. Meanwhile, the United States pressured Canada to abandon its independent project and instead purchase American systems. Political debates raged. Supporters argued that Arrow represented national pride and technological leadership. Critics pointed to spiraling costs and questioned whether Canada could afford to keep it alive. In 1959, the decision came down, the program was cancelled, existing aircraft were destroyed, and the Arrow never saw active service. The cancellation remains controversial to this day. Many see it as a tragic case of over-engineering, a plane that was too advanced, too costly, and too politically complex to survive. The Avro Arrow showed what was possible, but it also showed how brilliance without practicality can doom even the most promising design. Our fourth case brings us to the Soviet Union during the Cold War, where designers attempted to match Britain's revolutionary Harrier jump jet. The result was the Yakovlev Yak-38, the USSR's first operational vertical takeoff and landing, or VTOL, aircraft. On paper, it seemed like an incredible concept. A fighter that didn't need long runways could launch from small carriers or rough forward bases, giving the Soviet Navy flexibility it had never had before. In theory, it was a leap into the future of combat aviation, but in practice, the Yak-38 quickly showed the limits of over-engineering. The aircraft was badly underpowered, using separate lift jets and a main engine that created enormous strain and wasted weight. Its range was short, its payload tiny, and its performance lagged far behind conventional fighters of the era. In dogfights, it would have been hopelessly outclassed. Safety was another issue. The Yak-38 suffered frequent mechanical failures, and its emergency ejection system, designed to automatically eject pilots if the plane lost stability, often triggered at the wrong time, sometimes blasting airmen out of their cockpits without warning. The nickname, the jumping coffin, captured just how unreliable it became. In the end, the Yak-38 was more a demonstration of ambition than a true combat aircraft. It looked impressive in parades and training films, but its combat value was minimal. Compared to the Harrier, it was heavier, weaker, and far less practical. The Yak-38 remains a textbook case of over-engineering, a design that promised much, delivered little, and proved that not every futuristic concept can survive the brutal reality of war. Our final case brings us into the modern era with one of the most controversial aircraft in history, the F-35 Lightning II. Designed as a stealth multi-role fighter, the F-35 was supposed to do it all: air-to-air combat, ground attack, electronic warfare, and intelligence gathering across 3 different variants for the Air Force, Navy, and Marines. On paper, the Lightning II is extraordinary. It carries some of the most advanced sensors ever put into a fighter jet, allowing pilots to see and track enemies long before they are detected themselves. Its stealth design makes it nearly invisible to radar, and its software integrates data from across the battlefield, turning the F-35 into a flying command center. In theory, it's not just a fighter, it's an entire network in the sky. But the ambition behind the program has come at a steep price. Development dragged on for decades, plagued by delays, redesigns, and technical failures. Costs ballooned to over $1 trillion, making it the most expensive weapons program in history. Even today, the aircraft is criticized for high maintenance demands and complex logistics that keep many jets grounded. The debate continues: is the F-35 a stroke of engineering genius or a case study in over-engineering? Supporters argue it represents the future of air combat, bringing unmatched versatility and survivability. Critics say its complexity makes it fragile, too costly, and too reliant on perfect conditions. Like the warplanes before it, the F-35 shows that sometimes the line between brilliance and burden is razor thin, and history will be the final judge. Looking across these examples, a clear pattern begins to emerge. Nations fall into the trap of over-engineering for a few common reasons. Sometimes it's prestige, the desire to showcase technological superiority with a plane that looks like it came from the future. Other times it's political pressure, with leaders demanding a symbol of strength no matter the cost. And often, it's technology moving faster than logistics. Engineers can design something brilliant, but if supply chains, training, and budgets can't keep up, the aircraft becomes more of a liability than an asset. This is why so many over-engineered planes shine in test flights or parades, but stumble in real combat. They're too expensive, too fragile, or too complex to be used effectively at scale. By contrast, history shows that the true winners are usually the workhorses, aircraft like the P-51 Mustang, the B-52 bomber, or the F-16 fighter. Simple, reliable, and easy to maintain, these planes may not grab headlines, but they deliver results. In war, practicality often outlasts brilliance. These warplanes remind us that brilliance in design doesn't always guarantee success in battle. They were marvels of engineering, sleek, fast, futuristic, but sometimes brilliance became a burden. Engines failed, costs soared, and complexity made them unreliable when it mattered most. History shows that the aircraft that truly change wars aren't always the flashiest or the most advanced. More often, it's the dependable workhorses, the planes that could be built in numbers, maintained in the field, and flown day after day, that leave the biggest mark. So here's the question for you. Which of these aircraft do you think was the most over-engineered of all time? Was it the revolutionary Me-262, the costly B-58 Hustler, the cancelled Avro Arrow, the unreliable Yak-38, or even the modern F-35? I'd love to hear your thoughts in the comments. And if you enjoyed this breakdown, make sure to subscribe for more military archive deep dives into the machines, weapons, and technology that shaped history.